Guys, we're on section 2.8, last section of the chapter before your test, chapter 2 test. This is page 68. And the section is factoring polynomials completely. How can you factor a polynomial completely? Work with a partner, write the product represented by the algebra tiles, then multiply to write the polynomial in standard form. So the first thing is that these are already factored for you. So this is x plus 1. This is x plus 1, oops, and this is negative 2. And if you have a bunch of things sitting next to each other and there's no symbol, that's multiplication. So I'm going to go ahead and do x plus 1 times x plus 1 first. So x plus 1, x positive 1. You get x squared, you get 1x, x times 1 is 1x, you get another x, 1 times 1 is 1. When you combine like terms, you get x squared plus 2x plus 1. And after that, so I've already multiplied these now, and I have to multiply everything still by negative 2. In this case, that will look like this. And I just multiply everything by negative 2. So I could say negative 2x squared minus 2 times negative 2 is negative 4. And 2 times, or negative 2 times 1 is negative 2. So as a reminder, this is factored form. I'll write that, or type it, factored form. And this over here is standard form. And so the point of factoring is to go generally from standard form to factored form. But how could you look at something like this and turn it into that? And I will show you. That's the point of this section. So just a few examples here. Let's see. What do they have in common? They both have an x squared. So I could say x squared times what would make x cubed? X squared times x, x plus 1. And so now, actually, you could say this is unfactorable because there's no, there's nothing else I can divide both of them by except 1. Something like this. What do they all have in common that I could start by factoring right away? An x. They have x squared minus 4x plus 4. And you might look at this and be like, okay, well, is there anything else I can still do in here? And the answer is yes. I could say x times, we have a square root of x squared would be x. This would be the square root of 4 is 2, and since this is a minus, we know I can pretty much just write it out like this. X times x minus 2 squared. And again, these are just examples. Here, I could factor an x squared minus 1. And since the first and last terms are square roots, I should be thinking about special products. And in fact, this is just that x. Sorry. This is that x. I could say x squared minus 1 is the same thing as x minus 1 times x plus 1. And if you're not sure about any of these, just use the box and you could double check all of them. Okay. So we have a few, how can you factor a polynomial completely? Use your answer to question 3 to factor each polynomial completely. So in your notes, I would say start by factoring GCF if there is one. Sometimes there isn't. Like if you could divide everything by 4 or 4x, and it's usually a good hint. After that, look for a special product pattern. So that's something like a squared minus b squared, a squared minus 2ab plus b squared, or a squared plus 2ab plus b squared. And then if not, if there is none, factor by grouping. So use your answer to question 3 to factor each polynomial completely. So we'll start off here. Start by factoring GCF. Is there something that I can factor from all of these? And the answer is yes. An x. X squared plus 4x plus 3. And then look for a special product pattern. Can I take the square root of x squared? Yes, it's x. Can I take the square root of 3? No, it's going to be some number that I'm, you're not familiar with, but it's also not a whole number. What else can you do? If there is none, factor by grouping. So you would say x, 1 times 3 is 3. Things that add up to 4 but multiply to 3 are 1 and 3. So you could do that. So you say x squared plus x plus 3x plus 3. Or if it is your preference, which for some of you it is, or I would say many of you, you can use the box as well. Don't forget though that when you use this box, these two terms right here always have to add up to the middle term. And if they don't, then it doesn't make sense. So in this case, it will be x times x plus 1, x plus 3, and that's it. Let me know if you have any questions. Here, I'm going to go ahead and factor in x real quick because I can. Then I have x squared minus 6x plus 9. And here's a time where you think, okay, well, I start by factoring GCF. I look for a special product pattern. I have x squared and a positive 9. So I know I could take the square root of that, get x, take the square root of that, get a 3. But because this is a negative 6x, for this to work out, I would have to say x times x minus 3 squared. And this is now factored completely. If you're not sure about this, then you can go ahead and do a box where you have x minus 3 times x minus 3, and you work it out, and you'll get x squared minus 6x plus 9. Lastly, this is x. This is the same thing except a plus. So it becomes x times x plus 3 squared. Okay. Moving on. Factored completely, factored by grouping. So we have gone over factoring by grouping. Factored completely, I guess the definition, or not a guess, would be bad if I were guessing. But factoring, why can't I type? All right, well, I would say factoring by factoring until the polynomial is unfactorable. And you might wonder, oh, how do I know if it's unfactorable? Well, if we look at something like this, x times x plus 1, like you just develop a sense for when there's nothing else to do anymore. But if I said something like, oh, x times 3 plus 6, or 3 plus 6x, then you should be able to look at this and think, oh, well, I could still factor a 3 out of here, and you can. So this would be, 3x 1 plus 2x. And if you're not sure if you're right, if you multiply 3x, 3 times x, you get 3x, and x times 6x is 6x squared. So 3x times 1 is 3x, and 3x times 2x is 6x squared. You don't have to copy that, or you don't have to copy these parts. It's just an example. Okay. And I'm just going to go through these examples for you, or with you, rather. 3x squared plus 6x, again, you factor a 3x because they're both divisible by 3x. How do you know if you're right? 3x times x is 3x squared. 3x times 2 is 6x. Here, look for a difference of two squares or a perfect square trinomial. So here we have a square, and here we also have a square, and this is double that. So I could say x plus 2. Well, they already wrote it. I'll just talk about it. So x squared is here, 2 squared is here, and this term is double, or multiply by 2, everything in here. 2 times x is 2x, 2 times 2 is 4x. Or sorry, 2x times 2 is 4x, and that's how you get it. Here, it says into a factor trinomial, and then it says all this other stuff. You can make a table if you want, or a box, but I think personally factoring by grouping is the easiest thing. So 3 times negative 2 is negative 6. What multiplies to negative 6 but adds up to negative 5? You could say negative 6, positive 1, and then you rewrite 3x squared minus 6x, and so on and so forth, plus x minus 2. Don't forget, though, that the parentheses, or the things that you were multiplying by later, always have to be the same. And what will that look like? I will show you more specifically here. So I could factor x from this, and I get x squared plus 1. And don't forget that since the parentheses got to be the same, then what I can do is I can actually just write that first, and then think, okay, well, what would I multiply x squared plus 1 by to get back my original expression? And that is negative 4. So you go ahead and you copy the set of parentheses, x squared plus 1. So you have dealt with that. And what is it being multiplied by? It is being multiplied by x and negative 4. So that's how that goes. Okay. Let's keep moving. Factor the polynomial by grouping. So I will tell you what to factor, but since I've already gone over so many examples, I'm not going to, just work them out all the way. So we'll start off by factoring b squared here. Think about what you have left over. And remember that the second set of parentheses has to be the exact same. Here, what can I factor? You could factor an a from this. What could you factor from here? A b. Think about what goes inside there. Here, d squared and 2c, we cannot factor anything from besides 1. So what I'm going to do is I'm actually going to rewrite it, and I'm going to rearrange some stuff before I factor. I will say 2c plus cd, because now if you think about it, this is positive. Sorry, this is positive, so I can just write positive 2c plus cd. And then I have d squared plus 2d. So from this, you could factor a c. Oh, you know what? Sorry, this is still a little confusing because we're going to write it a different way. I would say, 2d and d squared. So you could factor a c from these, and then you could factor a d from these. So what I just did was I showed you can rearrange it, and that is a thing you can do. You can rearrange it in any order you want, in order to group things that have similar something that you can factor from both of them. So like I looked at this and I said, oh, d squared and 2c, I can't factor anything. Well, I have to write something together that you can break into groups and factor. So yeah, I would say for this section, if you get stuck, go ahead and make sure you refer to these guidelines. They're there for a reason. It says guidelines, they will guide you. And then if you have any questions, let me know. For instance, you could factor 4c here first. For here, there's nothing you could divide everything by, so you just start off by factor by grouping. 9 times negative 14. Here I would factor a 25x squared first. It gives me 4x squared minus 5. Or sorry, minus 1. And you can still factor this. You can factor this more, and if you're not sure, let me know and I'll come show you. Same here. There's more to factor here. We have c squared minus 1. And again, if you're not sure, keep going. There's more to do. And if you're not sure, go back to the guidelines and check in on what you think you could do. These are solving, which are we've already covered that as well. And you could factor this by grouping or by making a box, whatever you prefer. Okay, that's it. Let me know if you have any questions. Otherwise, good luck, and make sure you make full use of those guidelines.